Cool. All right. We are moving on to some notes right now.
Oh, we're doing bits again?
Yes, we're doing
Wait,
fetch again.
on it now?
No, because I want to show you some things.
Oh, sad.
We're in every direction upside down.
Alrighty. Cool. Listening up so I can show you this and then we can do a worksheet to help us understand what we are talking about. Okay, so expectation right now is that we are quiet so that way we can hear my notes. What you should be doing right now is just listening to me. You don't have to worry about writing anything down because you're going to be doing a worksheet to show application of the material. So we are going through the success criteria number 5. I can make observations on how current behaves in a parallel circuit. So what we're going to be doing is we're going to be building a circuit and we're going to be making some observations on what's happening. So, whoops, can I click things? Yes, here we go. We have a battery. We have our wires. Not going to make fire. We have one light bulb. And what I'm going to do is I'm going to make it nice and neat so that way if we were to draw a circuit, it'd be really easy for us to do that. So what you guys observed when you were doing the practical was that we had one light bulb here and it was bright. Now normally when we add another light bulb, it went dimmer, right?
Yeah.
But did it do that in this case?
Yeah, it went brighter.
Went brighter. I don't know if it would say it went brighter. It was the same brightness. So let's connect that up. We have some wires here. Like that. So we notice that if I connect another light bulb in what's known as a parallel circuit, the light bulbs stayed bright, didn't they?
No.
They should have. Yeah? All right, can we take the headphones out of ears to make sure you guys are listening? Okay. So what I want us to do then is I want us to measure current to see if that can help explain why did these light bulbs stay the same brightness. Now, something that we learned was that, does it matter where I put the amp meter?
Yeah. But what?
In a series circuit, does it matter where I put the amp meter?
Yes.
No, not in a series circuit. But what we're going to do is we're going to add it in a parallel. We're going to see what happens. So let's measure each of the light bulbs and how much current they're getting. So I'm going to add the amp meters in there. So this one's reading 0.9. What do you think that one's going to read? Sorry, I don't want that.
90.
Is it going to read 0.9 as well?
Yeah.
It's gonna be the same.
It's going to be the same. So both of these light bulbs have the same current. When we had 2 light bulbs last time, what happened?
What?
In a series circuit. Do you want me to put it up?
The other one, you just look at it straight. It won't the target looking thing.
Awkward.
You can just look at it.
All right, should I do a series one so that way we can compare?
What series?
So this is parallel, and I'll show you guys series again. So series is only one pathway. Actually, I might make a couple.
Why don't you just connect it?
So here's my series one. So I'm just going to build a couple circuits so that way we can see what's going on. It's going to be a little bit cluttered, but that's okay. We don't mind clutter.
Fire?
We're not going to make any fires.
Damn it.
I know, you guys probably made fires yesterday.
Wait, what fire? What happened yesterday?
Or not yesterday, when I was away last
Oh
week.
yeah, we made fire.
Yeah.
We actually.
We're going to understand why that happened too.
Simple.
All right.
Oh, sad.
So here are 3 different circuits. This is a series circuit. I know it's a series circuit because there's only one pathway. This here is a series circuit as well because it's only one pathway. And what we notice is that the current gets halved because I have 2 light bulbs now. So I took this current and I divided it by 2. This one here, though, is a parallel circuit. So I have 1, 2 circuits. Yeah? And with that two circuits, we see how they're both 0.9. So they both have the same current there. But we want to measure it also right here as well. Let's see what happens there. So we'll delete that wire. And we're going to add another ammeter. Now, what do you think that number's going to be?
10. Next minute.
It's 1.8. So you see how we have 0.9 and 0.9. And if I add those two together, what do I get?
10.
1.8.
Oh.
0.9 plus 0.9. All right. So we see here how the current's getting split up, isn't it? All right. So that's how we can observe how it is going. We notice that actually we're pulling more current from the battery. Now, you guys, we're doing some things like, let's increase the voltage of the battery.
Oh, that's super.
So the light bulbs get brighter, right?
I made a whole right of this.
And we see how the current's increasing as well. And if I keep increasing and increasing and increasing and increasing and increasing,
Yes!
fire. Do you see what happens?
No.
It's overloaded the circuit. So have you guys ever at home, you know how you plug in appliances? And every so often you have like the toaster and the kettle and the oven running. And then you notice how the lights then all turn off in the kitchen. It's because you've overloaded the circuit. You've put too much in there. So what you've done is you put too many appliances and now they're trying to draw too much current and it breaks my circuit. It causes a fault. That's how we can get fires in the home sometimes because of electricity. Yeah, it could be the sparks and stuff. So what do we put inside the house to help make sure that that doesn't happen? Do you guys know? All right. So to help protect our circuit, what we do is we put in something called a resistor. So if I keep increasing and increasing and increasing and increasing and increasing it, you see how this hasn't broken?
Yeah.
And that's because the resistor is helping protect it. Now, if that resistor isn't that strong, make it lower.
Yes,
I want a fuse actually, not a resistor. Let's break that.
Oh yeah, that. Just bring it neutral. Yeah, that one. That battery thing.
Fuse, that's what I want.
That's how we actually make fires with it.
All right, I'll show you guys this. So this is a fuse. You guys have these in your houses. That was probably too high for it. Let's fix it. There we go. All right, so in our kitchens, you plug in appliances. We've plugged in 2 appliances right now. We will increase our voltage. Trying to see where that break point is. Right there, okay. Fix it. Oh, nope, still too high. Decrease that a little bit more.
100.
Oh yeah, it's probably 20 actually. Good point. There we go. So you see how that circuit's working right now?
No. No, it is.
Yes?
No, it is.
All right, let's say this is my toaster, this is my oven, and let's go, ooh, actually I want to make a cup of tea as well, so I'm going to add another light bulb to represent my cup of tea.
Wait, why is the numbers different?
Because I changed the voltage here. So I've increased it. All right. So I've put that in. And we're going to watch what happens to this guy here.
Yes.
You see how that broke? Did it not cause a fire?
No.
No.
So that's what our fuse box does at home. So when you blow your kitchen appliances, it's because this guy has broken and you just go to the fuse box and you just switch it back on. So we plugged in too many appliances because we were drawing too much current. All right, take that guy out, put some wires back in. There we go. All right, so the other thing we can do is add switches. So let's say I want to control my various light bulbs. I can control it with a switch.
Oh, yeah, true. Then you just stop.
Now, do you see how I only broke this circuit and only this light bulb turned off? Yeah? If I put my switch over here Which light bulb do you think is going to turn off now?
That one.
The one in the first one.
Yeah.
Miss, I just discovered if you scroll down, there's stronger batteries.
Yeah.
100,000.
So if I turn this one off, just that light bulb, these two light bulbs still work. So that switch only controls one of the light bulbs. Can I have a switch that controls all three?
No.
Yes, you can.
Yeah. So it just depends on where we put the switch. Do we see that? All right. So our last item for today is I want you guys to be working on the second half of this page. So we did the first half as our do now. On the back side, it says current and parallel. And what we're going to do is figure out the math behind some of these guys. So let me go back to our instruction so you can see the video. So I can help you guys through some of the beginning bit of it. All right. So how many light bulbs do I have? Switch over to the back page of your sheet.
Oh, wow, there's a back.
There's a back page, and we're going to do both sides. All right, switch over to the back side. All right, how many light bulbs do we have? Two. 1, 2. Are they connected in series or in parallel? Parallel, because I have two potential branches here. Now, we are assuming the light bulbs are the same. So here's a light bulb, here's a light bulb, and we're looking at the amps. So we see how we split up my current here, so that one's going to be 7 as well. So amp number 2 is 7. If I do 7 plus 7, what do I get? 14. So do we see how that amp meter number 1 here is 14? Are we good? Yeah. All right, second one over here. This one is 6, and with that 6, it's going down 2 different pathways. So what should happen? Should divide, right? By how much? 3. The answer will be 3 because we're dividing by 2. So this is going to be 3 amps, and that's going to be 3 amps as well because when they add together, 3 plus 3 equals 6. So that's 3 amps, and that's 3 amps. All right, can you guys do the last 2 problems? Yeah? And then there's also, like I said, a general statement that you write about parallel circuits. Okay? So I'll touch base in the final kind of couple minutes of class to talk about this general statement. I do have another worksheet if you guys are finding this too difficult. So I'll do a little wander around and see who might need the other worksheet, okay? But that's what you're supposed to be working on. So we'll switch back to here. So what you should be doing right now is your SciPad page. I'm happy if you guys want to work together so we can have a little bit more noise in the classroom for that. And what you're trying to do is you're trying to make observations about how current behaves in a parallel circuit. If it's too difficult, I have another worksheet that you can do. And actually, I should add, if we finish early, you can play with the FET software. See if I can find it.
My name is Matthew.
Okay. There you go. All right. Shh. Listen up, because I see that some people are struggling. Take a seat. I'll do one more, and then you guys can do the last one. All right. So I'm doing this one here. All right. So we have current leaving, and that current is reading at 3 amps right now. You okay with that?
Yeah.
All right, when it gets to here, it gets split. It's divided. And it's divided by how many? How many wires are here? 1, 2, 3. So I do 3 divided by 3, and I get 1. 3 divided by 3 is 1. So amp number 3 should read 1 amp. Amp meter number 2 should read 1 amp as well. Then you see how amp meter number 1 here. Oi! Shh, listening. I'm trying to explain this so you guys can understand it. So we're going to show some respect. We're going to be quiet. All right. We see how in this one here, all 3 pathways have come back together, right? We've had it joined back. So we're going to add them all together again. So 1 plus 1 plus 1
equals 3A.
3A for this amp meter number 1. Okay? All right, do this last one here. So 12 is what we have, and we have how many? 4. So we need to figure out what the amps are here, here, and here. All right, give it a go. Nope. A1's not 3. All right, ready?
No, I'm not.
Okay. Well, what you're doing this now is listening to Miss Garlic. All right. So we see how this here is 12. What should we be doing right now? Listening. So let's have eyes up to show that you're listening. Let's look at our piece of paper so that way you can check your work. Actually, that's confusing instructions. Look up, and then as you're checking my answer, you can check yours. Okay. So. All right. So we have 12, and we see we have it splitting into 4 pathways. So if I do 12 divided by 4, what do I get? 3. So amp meter number 2 should read 3. Amp meter number 3 should also read 3. And then at this point, we add them all together again. So if I have 3, 3, 3, and 3, what should I get? 12, because they all have 3. Yeah, 12 divided by 4 is 3, and then when I do 3 times 4, I get back to 12. So that's what you should have gotten. All right. So our general statement about current in a parallel circuit is that current in a parallel circuit can split. All right. So current in a parallel circuit can split, but right now I just have given me a very basic answer. Let's think about what the because. How many pathways do I have? Do I have more than one? I have more than one. This one has 4, this one has 3, that one has 2, that one has 2. So we just need to have more than one pathway.
Wait, what? I didn't hear that bit.
More than one is the key word there. All right, so I want you guys to finish up that worksheet. Once it is done, make sure your name is on it, and I want you to put it into my blue box because that's how I'm checking your engagement for this lesson, is making sure that worksheet is done. So if it's not done, you better work quickly because the bell's going to go soon. Now, to recap today's lesson, what we were looking at was how current behaves in a parallel circuit. We should also be able to observe the light bulb brightness, and drawing circuits as a good practice. All right. So, just going to move on to the last slide, and then I'll move back to that one. All right. So, today we learned how current behaves in a parallel circuit. You can make observations about how light bulb brightness and current behaves in a parallel circuit. Got the words there wrong. And you should still know how to make circuits. So folders you can put in that blue box that's currently on the side next to the periodic table. All right, hand in that worksheet. So that way we have you ticked off. Oi, 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 that's not the spot where I want those folders, and those folders go into that big blue box next to the periodic table. Come back and fix it. No. The blue box stays here. Take those folders out. All I want in there is the worksheet.